In a static fluid, the pressure at any point depends only on the depth at that point, meaning to say the pressure increases linearly with depth. This is due to the weight of the fluid above exerting a force on the fluid below, which in turn increases the pressure. The mathematical relationships that describe this principle is given by the equation of P equal to rho h g, where P is the pressure, rho is the density of the fluid, g is the acceleration due to gravity, and h is the depth within the fluid. These equations tell us that the pressure at a certain depth in the fluid is directly proportional to the fluid density, the acceleration due to gravity, and the depth itself. This slide shows how to derive the equation of pressure equal to rho, height, and gravity. For this video, we are not going to explain about the derivation. The expression of P equal to rho hg shows that pressure within a column of liquid is influenced by three factors, which are the depth of the liquid density, and the acceleration caused by gravity. Interestingly, the equation for calculating this pressure doesn't include the variable air or area. This implies that the pressure at a certain depth in a fluid is independent of the shape or size of the container. And this is because pressure acts equally in all directions and not just downward direction. So, the pressure at a certain depth in the fluid is the same, whether you are in a narrow tube or in a wide basin, as long as the depth, the fluid density, and the gravity remain the same. As shown here, the pressure remains consistent at this depth regardless of the container shape. To summarize what we have been covered so far, the force exerted by a fluid on the wall of its container are always perpendicular. This means the force exerted by a fluid on the wall of its container is always perpendicular at a 90-degree angle to the surface of the container. The fluid pressure is directly proportional to the depth of the fluid and to its density. So this statement is a reflection of the equation for fluid pressure at certain depth, which is given by P rho hg, where P is the fluid pressure, rho is the fluid density, h is the height of the fluid column above point in questions, and g is the acceleration due to gravity. This equation shows that pressure exerted by a fluid increases with the depth of the fluid and its density. This is why pressure increases as you dive deeper into a body of water. And at any particular depth, the fluid pressure is the same in all directions. This is because fluid, by their nature, flow and fill their container and exerting pressure evenly in all directions. This is why, for example, a submerged object feels the same pressure on all sides. Fluid pressure is independent of the shape or area of its container. This statement is a reflection of the fact that fluid pressure is determined by the depth and density of the fluid and not due to the shape or size of the container.